So our goal in section 3.3 is to graph linear equations. We're going to graph them using 3 points, and 2 of the points are going to be pretty specific. I want you to include the x and y-intercepts as part of your graph. So one of the things you should pick up on is what those are and how to find those points. At the end of this section, we're going to work on graphing horizontal and vertical lines. Horizontal and vertical lines. You should know what those equations are and what they look like. But let's start with kind of a visual problem. That is problem number 12 from the book. Asked you to find the coordinates of the x and y-intercepts. So it's a fair one to start out with. So here we go. Now your y-intercept is where the graph crosses the y-axis. So what are the coordinates of that point where the graph crosses the y-axis? What are the coordinates there? 0, 2. So that's your y-intercept. How about the x-intercept? Where does it cross the x-axis? -3, 0. So let's write down both of those points. So this is problem number 12. So we've got our x-intercept is -3 and 0, and our y-intercept is 0 and 2. Our goal is going to be to try and find these points and use them in graphing linear equations. So to find the x-intercept, let's do a little thought experiment. Einstein was really good about doing thought experiments. So if you picture the x-axis is a horizontal line in which the y-coordinate is 0, no matter where you're at. So to find this, find the x-intercept, you're going to set y equal to 0. That's how you're going to find the x-intercept in general. What do you suppose we're going to do to find the y-intercept? Set x equal to 0. Good. Because on the y-axis, x is 0. So all up and down the y-axis, x is 0. So set x equals 0 to find your y-intercept. Let's stick with the visual part just one little bit more. We'll do 2 more problems, starting with number 14. So again, we're trying to find the x and y-intercepts. What's the x-intercept for number 14? -5, 0. Is there a y-intercept? No. Graph simply doesn't cross the y-axis. Last but not least, let's move down to problem number 16. What's the x-intercept? 0, 0. What about the y-intercept? 0, 0. So instead of getting 2 points like we did with problem number 12, we're only getting 1 point. And that's okay. Basically what's happening is your x and y-intercepts are the same in problem number 16. There's only one of them. It doubles for both. It's your x and y-intercept. Now we're going to use those points to help us graph linear equations. We'll start with problem number 20. So 5x plus 6y equals 30. And they're asking you to find the x and y-intercepts. Well, I'm going to organize myself a little bit here. I'm going to draw a little t-table off to the side. That's going to have my x and y coordinates. And one at a time, I'm going to set first x equal to 0 and then y equals 0. Let's see what kind of points I can come up with. If I set x equals 0, I'm going to find the y-intercept. So 5 times 0 plus 6y equals 30. 5 times 0 is 0, so this equation is just 6y equals 30. What does y equal? Y is 5. So 0, 5. Let's do the same thing. This time set y equal to 0. That's going to give me my x-intercept. 5 times x plus 6 times 0 equals 30. What does x equal? 6. So 6 and 0. And that's it. That's all they ask you to do is find the x and y intercepts. But let me show you a cool website that you might find useful. www.desmos.com. And it's handy for graphing things. So let's take a quick look at the graph of this, just to make sure that it matches our expectations. So you go there. Sometimes what I'll do is I'll hit the toolbar and hit projector mode. That way it makes this line darker. But you can type in your equations, like 5x plus 6y equals 30. You can even change the color. Let's go for blue. There you go. But what you see here is your y-intercept and your x-intercept. Those points match our expectation. Eventually what we're going to do is we're going to use these 2 points along with at least one more to try and graph these linear equations. But for now, all we had to do is find those points. Let's try that again with problem number 22, unless there's some questions about 20. So let's take a look at problem 22 then. 2x minus 9y equals 36. Again, let's do ourselves a little t-table over here, off to the side. We'll start by setting x equals 0 and then setting y equal to 0. So set x equals 0. That's going to be your y-intercept. And then set y equals 0. That's going to be your x-intercept. If I set x equal to 0, how does this equation simplify? All right, negative 9y equals 36. And to solve, I'll divide both sides by negative 9. What do I get for y? Negative 4. Hey. How about over here when we set y equals 0? What do we get for x? Jim? 18. Yeah, 18. So 18 and 0 and negative 4. Your x and y intercepts. Quite often when I ask you to graph these things, I'm going to ask you to graph them using 3 points. So what we would have to do is find yet another point. So you've gotten rid of the easy ones. The next one would be to set x equal to something or set y equal to something and try and find that third point. All of your points should lie on the line that we get when we graph these other two. So let's take a quick look at that graph. So I'll shut this one off, turn this one on, and you get something like this. So again, it kind of matches what we would expect. Here's your y-intercept, here's your x-intercept. But any point in between should satisfy the equation. So I'm going to ask you to graph, or at least find one more point. And for that, we're going to have to kind of think a little bit. This is where it gets a little bit more challenging to graph lines. I need to find one more point. What that means is choosing a value for x or choosing a value for y, and then figuring out the remaining coordinate. So does someone want to pick a value for x or a value for y? One for what? X or one for y? One for x. Okay, so let's pick one for x. And let's see what happens when we do for y. Chances are we're going to end up with a fraction. That's okay. It should still kind of match our expectations, at least enough. So let's set x equal to 1 and see what we get. 2 times 1 minus 9y equals 36. If I subtract 2 from both sides, I get negative 9y equals 34. Divide both sides by negative 9. I get y is negative 34 over 9. Probably not many of us would really feel happy about graphing this. Let's at least turn it into a mixed number. What would it be? Negative 3 and what? Negative 3 and 7/9. Not exactly friendly. But this is going to happen to you sometimes when you choose that third point. You're just going to get kind of an ugly number. Not much you can do about it. You can try and choose another point. Negative 3 and 7/9. Actually, a point that does work out good would be 2. Or excuse me, not 2, but negative 2 for y leads to 9 for x. But, you know, it's hard to always stumble upon these points. Let's take a look at those two and see if they fit. So at least one of them does. Oops, let's see. If you looked at 9 and negative 2, here's 9 and here's negative 2. So it seems to fit pretty well on that line. The other one's going to be a little bit more challenging. I can graph it this way. Let's see, it was 1 and negative 34 over 9. Yeah. So that point, it'd be tough to graph it for yourself, but it does fall on our line. All our points are going to fall on that line. All right. The good news is you didn't have to graph that one. We just kind of looked at the graph just for the extra practice. But we are going to start graphing these things. And that's going to start with problem number 28. So problem 28 is this. 3x plus 4y equals 12. I'm going to do this for you in class just the way I would want you to do it on an exam. We're going to graph the x and y intercepts and then find one last point. So let's make ourselves a little t-table here. X and y, 0 and 0. Let's set x equal to 0. That's going to give us our y-intercept. And set y equals 0. That's going to give us our x-intercept. And then we're going to need one last point. Let's start with the easy ones. setting x and y to 0. 3 times 0 plus 4y equals 12. The 3 times 0 disappears. What does y equal when x equals 4? Excuse me, never mind. What does y equal when x equals 0? 3. Flip things around. We'll set y equal to 0. 3x equals 12, so x equals 4. Two down, one to go. Now it's up to you what you want to choose next. Now if you're doing this at home, I'd stick with a value of x between 0 and 4 or a value of y between 3 and 0. You're free to choose anything you want, but then you might start having to make your graph really, really big to fit it. I mean, you could choose x equal 12. That's fine, but then you're going to have to make a much bigger graph. On your exams, I'll fit you out with graph paper. Actually, the graphs will be on the exams for you, so you won't have to worry about drawing it there. But at home, and even in general, it's not a bad idea to stick close to these values that you already have. So what's your choice? What would you want to pick for x or for y? 2 for x. All right, let's do 2 for x. Set x equal 2. Now let's think about this for just a second. 2 is right between 0 and 4 for x's. So what y value is right between 0 and 3? 1.5 maybe. Let's see what we get. 3 times 2 plus 4y equals 12. So let's subtract 6 from both sides. 4y equals 6. What does y equal? Six over 4. Better yet, 3 over 2. Can anyone rewrite it one last way? Yeah, 1.5 or 1.5. All right, that looks good. So I've got 3 points. Now typically, this one, especially if you end up with fractions, is going to be harder to graph because you're going to have to kind of estimate a little bit. But your handout has 2 different sets of graphs. On the front side, it's a little bit more zoomed in than on the back side. So choose the side where the graphs are numbered between, -4 and 4 on both axes. And we're going to graph number 28 here. 3x plus 4y equals 12. So 0 and 3 is up here. 4 and 0 is down here. The last one was 2 and 1 and 1/2. So here's 2 on the x-axis. 1 and 1/2, it's about here. And you can connect the dots. Notice all 3 points lie on the same line. They should. What if they didn't? What if you had 3 points that, one of them's up here, one of them's down here, one of them's here. What's that telling you? Yeah. Oops. Oh, hey. Hi there. Sorry about that. Hope you're not getting dizzy. Yeah, if you had 3 points that formed a triangle instead of a straight line, there's something wrong. So go back and fix it. And that's why I want you to graph 3 points. Let me give you a little demonstration here. Let me close my eyes. All right. I'm going to put a point on the board. And I'm going to put another point on the board. Can I draw a straight line between those 2 points? Yeah. Well, let me try and put another point points in a straight line just by luck, right? So if you're drawing 3 points and they're not all in the same straight line, then there's a problem, okay? These graphs are linear equations, and their graphs should be straight lines. If you're not getting 3 points on a line, go back and fix something. Are we okay with problem number 28? Kind of our intro example, because I want you to do, let's see, problem number 30 next. Problem number 30 looks like this. 8x plus 4y equals negative 24. And kind of like the last one, we're going to start by plotting our x and y intercepts. So I'll make ourselves a little table here. X and y, 0 and 0. Now the hardest part for you doing these things is for you to figure out what that third point's going to be. But at least get, partial credit. Set x equal to 0 to find the y-intercept. Set y equals 0 to find the x-intercept. Find those points. You are going to need one last point in order to complete the problem, but at least try and get partial credit. Now that last point might be a little bit challenging, but I think in this one there's a good chance you can come up with a nice value for x or for y that'll lead you to integer ones. But if not, it's not a big deal to work with fractions. They're okay. Okay, so let's set x equal to 0. I get 4y equals negative 24, so y is negative 6. If you set y equals 0, I get 8x equals negative 24, so x equals negative 3. Now, a couple of you ran into some problems because the points that you chose led to things that you couldn't easily graph. So, for instance, I think negative 4 and negative 14. Nothing wrong with that point at all. It just, unfortunately, it doesn't fit on our graph too well. So, let's see, another one I think was what, 2 and 10? Yeah, 2 and 10. 2 and negative 10. Yeah, there we go. 2 and negative 10. Again, it doesn't quite fit on your graph. So what do? I mean, you can either extend your graph or you can choose another point. What I would suggest is kind of stay close to home here. Let's pick a value of x between, say, 0 and negative 3, or at least close to those values. So let's pick negative 1. So if I set x equal negative 1, so negative 1 is between 0 and negative 3, I should expect a y value between negative 6 and 0. Let's see what happens. 8 times negative 1 plus 4y equals negative 24. So it's negative 8 plus 4y equals negative 24. To solve for y, I'll get rid of the 8. So I'll add 8 to both sides. 4y equals negative 16. What does y equal? Negative 4. So now I have something that I think will graph a little bit easier. Negative 1 and negative 4. On the back side of your handout, the graphs are a little bit more zoomed out, so it'd probably fit there a little bit easier than it would on the front side. So this is problem number 30. 8x plus 4y equals negative 24. Let's graph the points we can. That would be 0 and negative 6. That's down here. Negative 3 and 0 is here. And then let's go over to negative 1 and negative 4. So negative 1 and negative 4 would be about there. So again, all 3 points. And indeed, if you could extend this graph a little bit further, and it looks reasonable to think that down here at negative 14 you'd have a point when x equals 4 and y equals negative 14, or 2 and negative 10. Again, those look reasonable. Tough to see based on our graph, but they are right. Any comments on problem number 30 here? This is exactly the kind of stuff that I want you to be able to do. So if you're missing something, if something's not clicking for you, then it's a good chance to get some help. One thing that you could have done, I was kind of curious to see if anyone would ask about it, was in looking at the equation, you might notice that everything's divisible by something. Everything's divisible by 4. So if I divide the entire equation by 4, I actually get something that might be a little bit easier to work with. So I'd get 2x plus y equals equals negative 6. Yeah, so working with this would be the same as working with this. You're going to get the same exact points either way. So if you can divide out, it's not a bad idea. Let's try problem number 48. We'll do this one together. 4x plus 3y equals 0. Just do a quick sound check here. I want to make sure I didn't accidentally set off my sound. No, it's this one right here. Yep, still got sound. Okay, so Like the last couple, we're going to start out by finding the x and y-intercepts. So here and here, x and y. Let's begin by setting x equal to 0. So set x equal to 0. 4 times 0 plus 3y equals 0. That simplifies, right? Because 4 times 0 just disappears. It's 0. What does y equal? 0, right? If you divide both sides by 3, y equals 0 divided by 3. In what case is something like this undefined? Yeah, if you're dividing by 0. If 0 is on the bottom. But 0 on the top, that's fine. So 0 for x gives me 0 for y. Do I have to go back in now and set y equal to 0, find out what I get for x? No, we kind of already know, right? It's 0. So, all right, well, I still need 2 more points to graph this. How am I going to get 2 more points? And I'm open for ideas. Not all. Go ahead. Choose 1 for x? Sure. Yeah, you're just going to have to choose some values. So let's set x equal to 1. Thank you. So 4 times 1 plus 3 times y equals 0. 4 plus 3y equals 0. If you subtract 4 from both sides, on the left-hand side you'll get just 3y. On the right-hand side we get negative 4. Almost done. What does y equal? What do we have to do to solve for y? Judy? Divide by 3. So we get y equals negative 4/3. Thank you. It might be easier if instead of graphing negative 4/3, we turn this into a mixed number. How could I choose, or how could I write that as a mixed number? Negative 1 and what? 1/3. So 1 for x, negative 1 and 1/3 for y. All right, so we ended up with a fraction on that one. Boo-hoo. Sometimes you're just going to get stuck that way. But let's see if we can't be clever about a value for x or a value for y that we choose. When I choose something here for x, it'd be nice if I get a number that's divisible by 3, right? Because eventually when I solve, I'm going to have to divide by 3. So what if I just chose x equal 3? Let's do that. We'll see how that works out. So if I set x equal 3, I get 4 times 3 plus 3y equals 0. And at least this time I'm going to avoid fractions by, a somewhat clever choice of x. Now you don't have to avoid the fractions. That's okay. Fractions are numbers too. But, if you can, it's going to make your life easier. What does y equal in this case? Negative 4. By the way, did anyone figure out, can anyone tell me, geometrically, thinking about what the graph looks like, how come when I set x equal to 0 and then set y equal to 0, I ended up with the same point twice? Can anyone explain that geometrically? What's going on when you look at the graph? Going diagonal, how? Through what? Through the origin. Good. So what's happening is that this graph is passing through the origin. So the x and y-intercepts are the same. Usually when we're graphing these things, When you set x and y equal to 0, you get two different points because you have a different point for the x-intercept and for the y-intercept. That's not true in problem number 48. So let's graph that back on the front side here. Problem 48, 4x plus 3y equals 0. Let's take a look at our t-table as we graph that. So we had a point at the origin, 0, 0. Let's plot the integer one next. That was at 3, negative 4. Barely on our graph, but we're still there. And let's kind of zoom in a little bit more here. The last point is 1 and negative 1 1/3. So negative 1 1/3, that's somewhere down here. So it's between negative 1 and negative 2, and I kind of divide it up into threes as best I can. About here. You don't have to be so careful about it. The purpose of that third point is to help you look at your line and realize, okay, I got it, because they all lie on the same straight line. Your graph doesn't have to be pinpoint accurate. If I wanted that, I'd do it on a graphing calculator or some kind of a system like Desmos. There, nice. Do you want another one like problem number 48? Another one that goes through the origin? Okay. Let's do number 50 then. You do number 50. 6x minus 5y equals 0. Six x minus 5y equals 0. And like the last one, let's graph that and see what we get. Help each other out. It's okay. I mean, I can't always make it around to everybody. I try, but help each other out. That helps me out, helps you out too. Explaining it to somebody else reinforces what you know. Study groups are a great thing because you're going to get help one way or another. You're going to get help by helping somebody else, or maybe the recipient of the help. But it works out good either way. Like the previous one, try and come up with 3 points. So, I mean, kind of predictably, this is a follow-up to problem 48. When you set x equal to 0, you get y equals 0. So, trying to find the intercepts doesn't exactly work for us in this particular problem. Well, it's okay. Now, it occurred to me as I was walking around that if you want to get yourself nice integer points, let's think about what would be the lowest common multiple between 5 and 6. 30, right? So what do I put in for x to get 30 when I multiply these together? 5. So if I put in a 5 for x, so let's see what happens. 6 times 5 minus 5y equals 0. So that's 30 minus 5y equals 0. If I subtract 30 from both sides, I end up with negative 5y equals negative 30. So y equals 6. So yay, 5 and 6. So that one worked out okay. But a lot of you probably weren't able to find, nice friendly points. What happened if you chose a different value? Somebody give me a value for x that you chose that didn't work out so nice. 1? Sure. Let's choose x equal 1. If you set x equal to 1, 6 times 1 minus 5y equals 0. 6 minus 5y equals 0. I'll subtract 6 from both sides. You get negative 5y equals negative 6. When you divide both sides by negative 5, one thing that you should take care of is that the negative divided by negative is positive. So 1 and 1/5, or some of you wrote it as a decimal, 1.2. Either way is fine. Let's use the back side of our handout again, simply because the graph's a little bit more zoomed out. So my last point here would be, where was it? It was 1 and 1.2. Now that third point is really just kind of a checkpoint. I just want to make sure it's looking good. It doesn't have to be, graphed with, amazing accuracy. We've got points at 0, 0, and at 5 and 6, which is up here. And the last one is 1 and 1.2. So a little bit above 1. About there. Does that look reasonable? Do they all look like they're falling on the same straight line? Yeah, I'd say so. They're looking pretty good. Yay. So all set with number 50. Now in my morning class, I had some questions about graphing some problems, and there's more than one way to graph these types of things. You don't have to just graph x and y-intercepts. Sometimes, depending on the shape of the problem or its form, it's easy just to plug in values for x or for y. An example of such a thing would be if I had the equation y equals, 2x plus 1. Notice I have the y variable by itself. So it's easy to plug in values for x. Let's just do that right here. X and y. Since I have y by itself, we'll plug in 0 for x. 0 for x gives me 1 for y. If I want another point, plug in 1 for x. Now what do I get for y? 2 times 1 plus 1. 3. You could plug in negative 1. You could plug in positive 2. Let's plug in positive 2. 2 times 2 plus 1 is 5. So do you see the difference? Here I've got y already solved for it, so it's easy to plug in values for x. 0, 1, 1 and 3, and 2 and 5. And I get a quick graph. But let's mix things up a little bit. Suppose that I gave you an equation like in problem number 52. I'm going to get the most out of my scrap paper here. So let's just do problem 52 right here. And you're asked to graph, I think it's y equals -3. I can do kind of the same thing that I did with the last one, right? Because I've got y all by itself. And if you've got y all by itself, and you don't have to find x and y-intercepts, then let's just make ourselves a little t-table. We'll do pretty much the same thing we did with the last one. X and y. Let's plug in values for x. What are some easy values to plug in for x? 0, 1, 2, 4. So here's a trick question. If I plug in x equals 0 into this equation, what do I get for y? -3. If I plug in 1 in for x, what do I get for y? -3. And I think I see a trend. 0, -3, 1, -3, 2, -3, etc. It doesn't matter what x is, does it? Y is always stuck on -3. So it's called a constant function. So let's graph that. You can graph that back on the front side if you want. I think it'll fit a little bit better there. So graph those points. What do you notice about the line that you're getting? I know it's a straight line, but what's special about our line? What can you tell me about it that's special? All right, good. It doesn't touch the x-axis. How would you describe it? Go ahead. Yeah, it's a horizontal line. So when you have the graph, or when you have an equation of y equals something, y equals a number, that graph's going to be a horizontal line. Okay. Now, at the beginning of this section, I told you there's a couple things I wanted you to learn. One was how to graph an equation using x and y-intercepts and one more point. And the other thing I said was I want you to know the graphs of horizontal and vertical lines. Do I need to redo all my work if I gave you a different equation? If I gave you the graph of y equals 2, are you going to plot points to graph that? Or can you just come up with a graph? What's the graph going to look like? Yeah, straight line, another horizontal line on 2. Yay. I forget which problem it was. I think it's problem number 58. They asked you for the graph of y equals -1/2. Same thing. Just kind of have to estimate 1/2 or -1/2, but you're going to get a horizontal line through that level. What would happen if I gave you a different problem like number 56 of x equal 5? Yeah, this time it's going to be a vertical line. So the graph here, barely enough room for it on our handout, but we do have enough room. It's going to be a vertical line. And there's x equal 5. Now there's a couple ways that I can ask questions like this on an exam. I could give you the equation and graph it. A lot of times, though, when I give you stuff like y equals 2, people will put a point right there, and they won't graph the line. Oh, another way that I can ask it, an equation like, or a question like this, would be to, just draw a graph and say, okay, here's a graph. You tell me, what's the equation for that graph? X equal -2. These are some friendly questions. They're not designed to try and trick you. They're designed to say, all right, I asked you to know this. Do you know this? So make sure you study these. Don't forget them. But that's about it for section 3.3. Anything else that you'd like me to say or discuss on that one? I guess there is one last little variant on this. It's a problem like number 60. Problem 60 asks you to graph x plus 1 equals 0. Not necessarily clear at first glance what that graph's going to look like. I'll tell you what, how about if I subtract 1 from both sides? What equation comes out of it now? X equal -1. What's the graph of this one look like? McKenna? What's the graph of this going to look like? Yeah, another vertical line. This time through -1. So the only difference in 60 as opposed to the previous problems that you actually had to solve for x first. So I'll just draw a vertical line right through there. There's your graph. For homework, this is section 3.3. Try 11 through 59. Of course, as usual, that's just the odd problems.